continuous integration using Azure build pipeline. See, most of the times DevOps is all about efficiently creating a CI pipeline and CD pipeline. CI basically stands for continuous integration and CD stands for continuous delivery. So what exactly is CI pipeline? That is our focus in this particular session. And once we are good at CI pipeline, we would probably want to move into CD pipeline. But what exactly is this? See, whenever we build a pipeline, we are going to have multiple steps in the pipeline. And each step is supposed to perform a particular task. That task can be, as you can see here, build task, where the code is supposed to be built, or can be a test task, or can be validation of our code for security, vulnerability, licensing. All these things are different tasks which our code has to go through before it is going to be deployed into some environment. That environment can be dev environment, QA, staging. This aspect is taken care of by the CD pipeline. That means moving the code, the published code, into the production environment eventually. But going through various other environments also before production is the job of a CD pipeline. Definitely in this particular session, we are not focusing on the CD part. What we want is something which is going to be built, thoroughly tested, and all these operations performed. Of course, in today's session, I may not even go into test and SonarQube and white source security and stuff. So what exactly is an Azure pipeline? Azure pipeline is a cloud service. That is very important. It's a service which will automatically, the keyword is automatically, going to perform build, test, and deploy. Build and test are part of CI, and deploy will be part of CD. Yes, it is a fully featured continuous integration and continuous delivery service. Now, why do we call it as continuous here? Continuous integration and continuous delivery. Because we want automatically the steps to be performed. As soon as a developer builds the code, and he will create a pull request, and when the pull request is completed, we want the code to be automatically built and then deployed into the respective environment. And this is a continuous process. I make change, I create a pull request, the code is merged into the branch. From the branch, it goes into the environment after going through various stages. So before you use continuous integration and continuous delivery practices for your application, it is compulsory that you should see that your code is in some version control system. And there can be multiple version control systems, can be Git managed, GitHub Enterprise, or Azure repos, or you can even use TFVC, Bitbucket, and so many other version control systems are supported by Azure CI/CD pipeline. But point is, first you have to somehow ensure that your code reaches the version control system. That is important. And from the version control system, you are automating the build, test, and deployment of code. Now, important point to be noted, deployment can be not only in Microsoft Azure, but you can also deploy your code into GCP, Google Cloud, AWS, Amazon Cloud, and not only that, you can also deploy your code into on-premise physical or virtual machines. In any of these environments, platforms, we can deploy our code. And very important thing, the pipelines are language agnostic. You can write your code in Python, Java, JavaScript, or let's say Node.js, PHP, Ruby, C, C++, C#, Go, basically Go is Golang. Any language your code can be. So the pipeline remains completely independent of the language. Of course, the steps in the pipeline will definitely depend on the language of your programming applications. Azure pipeline to deploy code into multiple targets. Yes, there are cases where I would deploy applications not only in virtual machines. I can probably create a Docker container, basically a Docker image, and move that Docker image into a container registry. Or if it is an application, I have a setup and that I can deploy into a virtual machine. Or it can be an Azure app service, basically some PaaS service. Or even if there is a on-premise cloud, say you might have used Azure Stack, or you might have used OpenStack. These are on-premise cloud services. There also you can deploy your application. Different types of hosting platforms or hosting environments are there. These are all hosting. This is where the application can be hosted. You can deploy into Kubernetes cluster. You can deploy into Service Fabric. So whatever is the destination, yes, you can put your application through automated steps into the destination environment, destination platform. Now to produce the package that can be consumed by others, like sometimes I am going to build a package which my co-developers can use it. In short, I will build something like a class library. And this class library is a ready-made collection of classes, reusable code, which probably can be used in multiple other projects. So using CI/CD pipeline, we can move those packages to NuGet, which is a public library. NPM, NuGet is for .NET, NPM is for JavaScript, Node.js packages, Maven, which is for Java. So you can publish your packages to a built-in package management repository in Azure pipeline. So specifically there is a Azure artifact, a separate section where you can publish all these packages. And from there you can consume in other pipelines, other repositories. Yes, something which we are going to cover almost towards the end of our course. But today focus is on just a CI pipeline, and in the CI pipeline the source of the code is going to be a repository. Azure repos is what we are going to work with, but it can be GitHub also and all others, Bitbucket, Subversion, all these things can also be used as the source for your code. Now what is important is few terms you have to go through. Pipeline. Why are we calling this as pipeline? Because it's a continuous series of steps where everything is categorized in terms of stages. So a pipeline defines a continuous integration and deployment process. It is made up of one or more stages. Little very early to make you understand what are stages and stuff. But yes, a pipeline is made up of most of the time multiple stages. And each stage is supposed to perform a set of tasks. Each stage is again made up of many tasks which are also called as steps. And the task can be to build, the task can be to test, task can be to execute some PowerShell script, task can be to run a command line script. It can be any task. So it can be thought of as a workflow that define how to build, test and deploy steps, and deployment steps are run. So basically pipeline, as the water flows through the pipeline, our code is going to flow through the pipeline. So whenever we submit our code changes here, we can start an automated build. So the pipeline runs when we submit the code changes. Obviously, the code changes are submitted to the repository only. Yes, if you want, you can configure the pipeline to run automatically. But in case you don't want it to run automatically, you can initiate the pipeline manually. And not only that, you can also say a pipeline should run at a particular point of time in a day. Maybe suppose if I am going to deploy into a test environment and I want all the job which is done by the developer in a day and thoroughly tested and pushed into the repository, maybe sometime in the midnight 12 o'clock or midnight 3 o'clock, we want the pipeline to run and deploy our code into the test environment, where next day morning the testers would come and do the testing of the application. So pipeline can run automatically, pipeline can run manually, or a pipeline can be triggered at a particular point of time in a day. That's how you can have a pipeline. So pipeline is that. Now what is this pipeline going to do? every time you execute a pipeline, the executed instance is called as a run. So run is an executed instance of a pipeline. So imagine if you are a developer, you would understand in simple language. If this is a class, you can say this is an object. Once we create a pipeline, the same pipeline is going to run multiple times. Each execution is going to create its own log. That log, whether the pipeline was successful, the pipeline was failure, and if it was successful, what was the output generated by each task? If it was failure, what was the reason when the task executed and why it failed? All that we can view through a run of a particular pipeline. So yes, a pipeline executed is called as a run. And I already told you a pipeline has to be triggered. The triggered can be one of these: automatic, standard, manual, all these. And of course, all these are based on code which is come into the repository. And then we have agent. Now what is this agent? See, we are talking about the steps to execute. These steps have to execute. Where are these steps going to execute? Definitely it needs some computing power. It needs a machine on which these steps have to execute. That machine on which all the pipeline is going to execute is called as agent. So an agent is actually a software on a machine. Ideally speaking, agent is a software which is listening to the instructions from the pipeline and executing on that machine. For example, I stay in, let's say, India. I need something with Singapore. So I would put my agent in Singapore, and from here I will give him instructions to execute those instructions in Singapore. So agent is like that. Agent is a software which we are going to deploy on a particular machine, which can be a physical machine, which can be a virtual machine, and instructions are going to be executed on that particular machine, and the instructions will be issued by the pipeline when it is run. Yes, agents can be of two types in Azure especially. It can be Microsoft hosted agent or it can be self-hosted agent. In context of Microsoft hosted agent, Microsoft will give us those ready-made machines with agent software which is going to execute my pipeline. Whereas in case of self-hosted, we have to build a machine. We can build that machine in our on-premise environment. We can build the machine as a virtual machine in cloud. But on that machine, we have to run a special software, which is agent software, and then use that machine for execution of a pipeline. Definitely, these things will get clear more, when we do a practical demonstration. Very important is build artifact. The process of going through all these steps is eventually going to generate some output. That output is what we are here calling it as build artifact. Now don't ever get confused between build artifact and the Azure artifact which you might have seen in the DevOps. On the left hand side, we see Azure artifacts. If you select a project, this is Azure artifacts. This is different. And what we are talking about, build artifact, is different. Today only you will see that some output like a jar file or a zip file or maybe a set of files of various formats, exe file, a Docker image, any of these files produced as a result of executing the pipeline will be called as a build artifact. What are the benefits of CI? Continuous integration provides benefits to the development process. Your process will improve basically. Improvement of code quality. Why? Because here only you are doing testing. And probability is there, you might have built your code and it got tested and it failed here. So as soon as I make a pull request complete, the build will execute and test will execute. Immediately then and there I would know, oh, something is wrong and the quality of the code can be improved. Triggering automated testing for every code change. Reduce build time because it's automatic. See, ultimately all the advantages are because it is automatic. So if build time is reduced, rapid feedback can be provided, and because rapid feedback is provided, we can early detect the problems before it actually goes into even development environment. We have some ways here. We can create some build policies, and through those policies, branching policy, if you remember, one of the branching policy can be to start a pipeline, and only if the pipeline successfully completes, we would allow the pull request to complete and merge with the branch. Otherwise, pull request itself will fail because the pipeline fails. Like that, we can build a system here. Better managing technical debts. Now, what is this technical debt? That itself is a big question mark. For example, taking shortcuts in programming, not naming your variables properly, or not commenting your code because of the laziness today, or not finding the right algorithm for implementation of code which is most optimized. Somehow you become output oriented. Today you will get the result, but then it is going to become a technical debt, which over a period of time will only accumulate, and clearing that debt is going to be expensive. But with CI pipeline, with something like Sonar Cube or Sonar Cloud, technical debts can be detected then and there, which unless resolved will not let my pipeline to continue. So those kind of technical debts, code analysis can be done through tools like Sonar Cloud, Sonar Cube. Yes, reducing long, difficult and bug-inducing mergers. So whenever merge is there, there is always a possibility of what? Merge conflict. There is always a possibility of merge conflict. But with the pipeline there, I can instantly merge my code, test it, everything is fine, go ahead. So these kind of benefits, increasing confidence in code base, health long before the production deployment. So it's going through a process. Ultimate point is what? We are not just copying and putting the code in the destination. We are letting it through a proper process to generate some artifact. The artifact which is produced here would then go and get deployed into dev or QA or stage or production. So CI pipeline plays a very, very important role in producing a build output before it gets deployed into the environment. So yes, with this we complete about what is CI pipeline. And we are going to next see how to create the CI pipeline step by step.